We have total 6 circuits. In this alternating current, total we will be having 6 circuits. So 6 cases basically. So first case we are going to study. What is the first case? Purely resistive circuit. Purely resistive circuit. So what is the purely resistive circuit? Only resistor will be there. There will be no inductor. There will be no capacitor. Correct? So like I can draw the circuit like this. So only resistor is there. There is no inductor. There is no capacitor. And there is AC source. This is AC voltage. Okay. The voltage is V0 sin omega t, suppose. Voltage is V0 sin omega t. The resistance of this resistor is R. Draw. Correct? See, last class I told one more thing, that if I draw these small things, you should remember always. Okay? If I draw like this sin theta, then this vector will be what? Cos theta. And what about this vector? This will be minus cos theta. Correct? If this vector represents sin theta, this vector will represent cos theta, and this vector will represent minus cos theta. Correct? Now, in purely resistive circuit, we just have one resistor. There is no inductor, there is no capacitor. This voltage is AC source, means this voltage is not constant. It is changing with respect to time, as well as its direction is also changing with respect to time. Correct? So if I write the voltage, so voltage across this resistor, so voltage across this resistor will be what? V0 sin omega t, same voltage. V equals to V0 sin omega t. If I ask current, what is the current? So current is what? We can write now, like general formula I am telling. Current we can write voltage divided by net resistance. What was net resistance? See, Z. Net resistance. Correct? What is net resistance? Z. So I can write that current equals to voltage divided by net resistance. Now here net resistance XL is not there, XC is not there. So net resistance will be what? R, just R. See now, and you can put the formula from here, you can check. See, XL is not there, XC is not there, so 0. So under root only R is there, so under root R square is what? R. So net current we can write voltage, that is V0 sin omega t, divided by net resistance, which is R. Correct? And finally what we can write? This V0 by R we can write I0. So I0 sin omega t. Where what is I0? Where I0 is 0 divided by R. Write down. Okay? Done? See, we have one thing called phasor diagram. Phasor diagram. Now what is a phasor diagram? It is a vector representation of, current and voltage. Current and voltage. Where, see, vector is given by two things. Vector has two things. One is magnitude and another is direction. So magnitude, what will the magnitude of this vector? So magnitude will be peak value. Peak value, I will tell how to draw and all. And direction is phase of current or voltage, whatever, current and voltage. Okay, if you want to write, you can write, you can leave out also, because this is theory is not that much important here, but understanding of this phasor diagram, that is more important. But what is phasor diagram? It is a vector representation of current and voltage. Okay, and if we represent them with a vector, magnitude will be the peak value and direction will be the phase of current and voltage. What I am saying, like suppose when we are, because right of first case we are dealing with the first case only, that is purely resistive circuit. So what was the voltage in purely resistive circuit? Voltage was given by V0 sin omega t. What is the current? Current what we got? I0 sin omega t. Okay. So what I am saying now, what is phasor diagram? You have to represent voltage as a vector. You have to represent current as a vector. So vector, you draw the line and one arrow is there. Okay. So the length, the magnitude of this line will represent the peak value, that is V0, maximum value. What is the maximum value of voltage? V0. What is the maximum value of current? I0. So if I want to represent this voltage by a vector, if I want to represent this voltage by a vector, what I will do, see, like suppose this is my y-axis, this is my x-axis. Okay, so voltage length will be what? Representing what? V0, maximum value. And see, this angle will be decided by its phase. So what I can do now, see the vector first, you will be able to understand. See, this is voltage vector. The length, it represents V0, and this angle will be theta. Theta means omega t here. This angle will be omega t. Correct? This is the voltage. This is the net voltage or voltage. Again listen, how we are representing? Voltage, just we are representing, don't think about physics. Think all these things are like logic and assertion reasoning. Voltage, what we are doing, we are representing the voltage as a vector quantity. Okay, first. So vector quantity will have length, na? So okay, I have drawn some length. Its length represents what? Magnitude. What is the magnitude I told? Magnitude is peak value of voltage. Like here, what is the peak value of voltage? V0. Correct. Now, some direction also I have, this vector is also based on direction also, no? So direction is also important. So direction, what I told, you have to look at, when I am saying direction, so you have to look at the phase. What is the phase? Here, omega t. So this will be the angle, omega t. Correct. Now second, if I draw now, when I will draw the current, it will be more clear what I am saying. In the same diagram, I have to represent current as a vector. So what I will do, current again, it will have magnitude as well as direction. So magnitude is how much? I0. Acha, I0, what was I0? I0 was V0 by R. So I0 is more or V0 is more? Can you tell? V0 is more, na? I0 is less. See, we are dividing, na? So any number which is divided by any another number, it will become small, na? Like suppose 10, we divided by 2, so it will become small, na? So definitely I0 will be less than V0. Means I0 this vector I will draw length lesser than this length. Correct? What I am saying, current, when I will represent it as a vector quantity, I will draw its length smaller than this length. Why? Because its maximum value, that is I naught, is less than V naught. First thing. Second, what will the angle for this current? Again omega t. See, here also omega t. Means current you can't draw like this. This will be wrong because angle will change now. Here also angle is what? Omega t. Here also angle omega t. So basically we should draw in the same line. So current will be like this. See, like this, but little bit less because its value is less. It will be little bit smaller. So this is current. Okay. So you can see voltage and current in the same direction. Okay. So you draw this first. Acha, whatever voltage, see this, whatever voltage we are having, this same voltage will be across this. Whatever voltage we are having here, same voltage will be across this. Means voltage across resistor, voltage across resistor, this will be same, V naught sine omega t. Okay. So 2 points you should write. So there are lot many points, but 2 points you write separately, like here. That voltage in the resistor and current, they have same phase. See, they are having the same phase now. You don't know what is phase. Phase is that something which comes after sine. So here also omega t, here also omega t. So voltage across resistor and current, VR and current, they have the same phase. Same phase. VR and current, they have the same phase. Means VR and current will always lie in the same line. See na, same phase. Second point, here in purely resistive circuit, what we can see, that the phase difference between voltage and current, voltage is V naught sine omega t, current is I naught sine omega t. So between voltage and current, this phase difference is what? 0. No phase difference. What was phi? See, here you have written. I started this with this. What is phase difference? Phi. It is a phase difference between net voltage and current. So what you can see, there is no phase difference. There is no phase difference between the voltage and current. So phase difference I have written 0. See now, voltage also omega t, current also omega t. So there is no phase difference. So phase difference is 0. Third, if I ask what is cos power factor, so power factor I told na, cos of phi, and power factor I have given the formula. Let me check. Oh, power factor I have not given. You write here R divided by Z. R divided by Z. You write here power factor is R by Z. So power factor, if I say, so power factor you can check. Power factor is R by Z. So R by Z. In this case, Z is equals to what? R. In purely resistive, Z is equals to R. So Z is equals to R. So R by R, it is coming 1. Cos phi 1. So power factor is 1. And you can check like that also. Phase difference is what? 0. Phase difference, how much it was coming? Phase difference 0. So cos 0, 1. So always remember that power factor they ask in purely resistive circuit, it is 1. Average power, they ask average power. Tell me what will the average power? So average power formula VRMS, IRMS, cos of phi, and cos of phi is what? 1. So VRMS into IRMS, or what was VRMS, IRMS? Virtual power or instantaneous power. Virtual power, right? Virtual power or apparent power. So what we can see, average power is equals to virtual power for purely resistive circuit. See, we have 6 cases. 6 cases. In all the cases now, some common things are there that they will ask. First thing they ask, that is what is the phase. This is the first question they ask. Second, what is power factor. Power factor. Okay. Third, they will ask what is average power. Fourth is diagram, phasor diagram. Okay. Fifth is net resistance. One, two, three, four. These 5, 6 things now they repeatedly ask in all the 6 cases. Okay. So you have to remember these points. All the points which I am telling now, all the points are very important.